Okay, let's dive straight in. The future of, well, the German and European automotive industry, and honestly, a huge chunk of our industrial future, it really hinges on battery technology.
Well, it absolutely does.
But what if the current battery king, lithium-ion, face a real challenger? What if there was something, a potential game changer that could maybe reshape the entire field for our manufacturers, for our economy here?
That's exactly the question, and that's what we're looking into today.
Yeah, this deep dive, we're really zeroing in on this emerging world of sodium-ion batteries.
And specifically what it could mean for Germany and Europe. The car industry, yes, but also, broader industry, our economic footing, even geopolitics. It's all about staying competitive long-term here in Europe.
Right, because this stuff gets technical fast.
It can do, yeah. Our sources for this, just so you know, are a pretty detailed strategic analysis on sodium-ion tech and also a recent piece about CATL. They're a huge player and their plans for mass production. So we're digging into the science, the economics, and like I said, the geopolitical side of things for Europe.
Exactly. Our goal is to cut through that noise, really, and give you, our listener, a clear picture of why sodium-ion matters, why it's relevant for, say, Germany's industrial future. Expect some maybe surprising facts and hopefully a clearer idea of the shifts we might see.
The big question being, could sodium-ion be, well, a key piece of the puzzle for keeping Europe competitive in the long run?
Okay, so to answer that, let's set the scene. Where are we right now?
Well, right now, it's lithium-ion. It dominates EVs, energy storage. Its big advantage has been that high energy density. Packs a lot of power for its weight.
It's definitely been the engine driving the EV revolution so far, no doubt. But relying solely on lithium-ion comes with baggage, doesn't it? Our sources point this out pretty clearly.
It does. There are definitely pressures pushing us, especially here in Germany and Europe, to look for alternatives.
Like what? What are the main ones?
Well, first up, cost. Simple as that. The prices for lithium, cobalt, nickel, they can swing wildly, and they're high. That puts real pressure on making EVs affordable and makes big grid storage projects financially tricky here. The analysis we looked at, it mentioned a projected tenfold increase in lithium demand annually by 2028 compared to just 2017.
Tenfold. Wow. That kind of demand spike.
Yeah.
It naturally raises worries about stable pricing for our industries,
Yeah,
right?
absolutely. And it's not just the price fluctuations, it's the supply chain itself. Where do these materials actually come from?
Yeah, that's the other big concern.
Exactly. The analysis really highlights the risks there. Mining is concentrated, okay, but the processing, that's even more concentrated. China has a very, very strong position, especially in processing graphite, cobalt, lithium, manganese.
So that makes Germany quite vulnerable.
It does. Vulnerable to, well, all sorts of things. External shocks, maybe resource nationalism where countries keep materials for themselves, export restrictions, maybe even cartels forming, and just general political instability in some mining regions.
Yeah.
Plus, the mining industry itself is pretty oligopolistic. A few big companies control a lot. Not always great for price stability for the buyers like our manufacturers. And the World Bank thinks demand for these minerals could jump nearly 500% by 2050.
500%. That's a huge amount of pressure on a supply chain that's already looking a bit shaky for European needs.
It really paints a picture of potential bottlenecks, doesn't it? Real vulnerabilities that could hit German and European manufacturers hard.
And there are ethical dimensions too, right? Beyond the economics and logistics. Lithium and cobalt mining.
Yes, the sources bring that up too. Concerns about water use and lithium extraction, damage to ecosystems, and then the labor conditions, particularly for cobalt coming out of the DRC. It's complex and often troubling.
So all of this together, it really underlines the need for, well, for something else, or at least diversification.
Precisely. Which is where sodium-ion starts to look really attractive as a potential solution for Europe. It addresses many of these pressure points.
Okay, let's get into it then. The tech itself. What are the actual advantages of sodium-ion? And crucially, how does it stack up against lithium-ion? Maybe specifically LFP, lithium iron phosphate, which seems to be the go-to for more affordable lithium batteries now.
Right, that LFP comparison is key for the German and European auto industry. Our analysis had a helpful breakdown. Let's start with energy density, how much power you can pack in.
Okay.
Historically, sodium-ion lagged behind, but the gap's closing. The latest cells, like the ones CATL is pushing, are hitting around 160, 175 watt-hours per kilogram.
And LFP is?
Modern LFP is roughly in the 140 to 180, maybe a bit higher, WH/kg range. So sodium-ion is getting really competitive there. Still not quite like the high-nickel chemistries and premium EVs, mind you.
But for, say, more mainstream cars for European cities or maybe stationary storage for the German grid, it's becoming viable.
Exactly. Where absolute maximum range isn't the only factor, it's becoming a serious contender.
What about size, though? Does it take up more space? Volumetric density?
Yeah, that's a point where LFP still tends to have an edge. Sodium-ion generally has a lower volumetric density, so for the same energy, it might need a bit more physical space.
Could be an issue in tightly packed cars.
It could be, but for grid storage here in Germany, or maybe in vehicles where space isn't the absolute top constraint, it's less of a big deal.
Got it. So maybe slightly bulkier, but similar energy weight-wise to LFP now. What about charging? Speed is a big one for EV adoption, especially for German consumers maybe used to faster refueling.
This is actually a really promising area for sodium-ion. The analysis points to excellent power density. It can handle high charge and discharge rates, potentially 5C or even more.
5C, meaning?
Basically charging the battery fully in about 1/5 of an hour, so 12 minutes. Some tests show 80% charge in just 10 or 15 minutes. CATL is definitely highlighting this fast charge capability.
Wow, okay, that's fast. Faster than LFP generally.
LFP is getting better, but sodium-ion seems to have a potential fundamental advantage here for really rapid charging. That could be a major selling point in Europe.
Definitely addresses a key concern for buyers in Germany. Okay, how long do they last? Cycle life. That's vital for EVs and grid storage investment here.
Both are pretty good, actually. LFP is known for lasting a long time, thousands of cycles, maybe 3,000 to 10,000 even.
Right.
But some sodium-ion types, especially those using things like Prussian blue materials, are showing really impressive results, too. Over 3,000, even up to 6,000 cycles with good capacity remaining. So longevity-wise, it's competitive, potentially even better in some aspects.
Okay.
Of course, we still need more large-scale, real-world data over years of use, especially under German or European conditions. But the lab results are challenging lithium-ion's dominance on durability.
Encouraging. Now, safety. Always a huge topic with batteries, especially in cars on, say, the Autobahn. How does sodium-ion compare?
This is a big plus for sodium-ion. Generally, it's seen as thermally more stable, less prone to overheating, thermal runaway, compared to lithium-ion, including LFP. It's down to the chemistry.
Okay, inherently safer.
Yes. And maybe the biggest safety win. You can transport and store them completely discharged at 0 volts.
0 volts. How does that help?
It massively reduces fire risk during shipping and storage, simplifies the whole logistics chain for manufacturers and distributors in Europe, fewer safety precautions needed, potentially lower costs, fewer accidents. It's a fundamental shift, really.
That sounds like a huge practical benefit for the entire European supply chain.
Okay.
What about weather? We know lithium batteries can lose performance in cold German winters.
Another strong point for sodium-ion, the analysis shows much better low-temperature performance. They keep a high percentage of their capacity, like over 90%, even at minus 20 Celsius, and they can operate down to minus 40 C.
Minus 40, wow. And LFP struggles in the cold?
Yeah, LFP performance typically drops quite significantly in the cold, often needs battery heating systems, which uses up energy itself. So this cold weather robustness of sodium-ion is a major advantage for places with proper winters, like much of Europe. Less energy wasted on heating the battery, better range in the cold. CATL highlights this too.
That alone could be a clincher in many European markets, including Germany.
Okay, what about the materials inside? We talked cost pressures earlier, but any other material advantages for European industry?
Yes, definitely. A neat one is using aluminum for the anode current collector. In lithium-ion, you usually need copper, which is heavier and more expensive.
Ah, okay, so aluminum saves cost and weight.
Exactly. Contributes to lower overall cost and potentially lighter batteries for European car makers. And then there's a core advantage. Sodium itself. Abundant, globally distributed, unlike lithium. Plus, many sodium-ion chemistries avoid cobalt and nickel entirely, using much more common iron and manganese instead.
Which gets back to those supply chain and ethical concerns we talked about earlier.
Precisely. It offers a more secure, potentially less volatile, and ethically cleaner material base for building batteries here in Europe. Okay, so summing up the tech side. Sodium-ion looks compelling on cost, safety, cool performance, fast charging, and the energy density gap with LFP is narrowing significantly for many relevant European applications. Let's dig into those economics more. lower raw material costs seems key for Germany and Europe.
It's absolutely central. Sodium, as we said, is everywhere, one of the most common elements. Unlike lithium, think sodium carbonate versus lithium compounds, the price difference is huge. And sodium prices are historically way more stable.
Right.
The analysis estimates raw material costs for the cathode, the positive electrode, could be 50 to 80% lower for sodium-ion compared to LFP. 50 to 80%.
Right.
Then add in avoiding cobalt, nickel, using aluminum instead of copper. The potential for cost reduction for European battery makers is massive. It points towards cheaper EVs and grid storage simply because the ingredients are cheaper and more available.
And cheaper ingredients should mean cheaper batteries overall for German and European end users.
That's the logic. Once production scales up, predictions are for sodium-ion cell costs to be maybe 20 to 40% lower than equivalent LFP cells.
20 to 40% cheaper.
Plus, remember the simpler logistics from the zero-volt transport and less need for complex heating systems in cold weather. That all adds up to potentially lower system costs, too, for manufacturers here.
So we could be looking at genuinely more affordable electric cars and energy storage across Germany and Europe. What kind of markets could this open up for our industries?
Oh, huge potential for the European market. Lower costs could finally push EVs into the truly affordable entry-level segments. Urban runabouts, city cars, two-wheelers, light electric vehicles, all very popular in European cities.
We're already hearing about some manufacturers planning this, right?
Yes, reports suggest companies like BYD are looking at sodium-ion for smaller, cheaper models. And then there's grid storage. The cost effectiveness plus the long life and safety makes sodium-ion super attractive for large-scale batteries to support renewable energy across Germany and the EU. Costs per kilowatt hour and cycle life are king there.
It sounds like it could really help democratize both EVs and renewable energy storage for the German and European market. That's exciting. And you mentioned earlier that existing factories could be adapted.
Yes, that's a crucial point for established players in Europe, like German battery makers. They don't necessarily need to build entirely new plants. They can retrofit a lot of their existing lithium-ion production lines.
Which means faster scaling, less upfront cost.
Exactly. It helps accelerate getting these batteries to market and allows European companies to compete more quickly in this emerging space.
Okay, the economic case seems strong for sodium-ion within the German and European context. Let's shift gears slightly. Geopolitics. Resource security is a massive topic now. How does sodium-ion change the game for Europe there?
I think this is where sodium-ion offers a really powerful strategic advantage, especially for us in Europe. Sodium is everywhere, near universal availability.
Unlike lithium, cobalt, nickel.
Exactly. Which means less reliance on the handful of countries controlling those resources. For Germany, for many European nations lacking significant lithium reserves, this diversification is huge for energy security, reduces our dependence on potentially volatile regions or suppliers,
Right.
and it opens the door for building more independent processing capacity, maybe even within Europe itself, because the raw materials are just so much more widely available. It could genuinely lessen the current reliance on China's dominance further down the value chain.
So it's not just about saving money for German companies, it's about reducing strategic vulnerabilities, strengthening Europe's position.
Precisely. A sodium-based supply chain promises more stable material prices, better resilience against trade disputes or export bans that could hit lithium. It safeguards European industries, and it creates real opportunities to build up local value chains here in Europe, strengthen our own industrial base instead of just importing critical materials. Plus, the ethical side, avoiding cobalt, potentially lower environmental impact from sodium sourcing compared to some lithium methods, it helps build a more sustainable battery industry in line with European values.
So good for the German wallet, good for industry, potentially good for energy independence, and a more stable geopolitical position for Europe. Sounds almost too good to be true. There must still be challenges, right? What's the realistic outlook for adoption here?
Oh, absolutely. It's not perfect, not yet anyway. There are hurdles still for wide adoption in the German and European markets. Energy density, as we said, is still the main one compared to high-end lithium-ion like NMC or NCA.
So maybe not for the top-spec long-range EVs just yet.
Probably not immediately, though research is pushing towards 200 Wh carrels and beyond. But yes, for now, it might limit use where absolute maximum range is the selling point for certain consumers. Another challenge is scaling the specific supply chain. Well, while sodium is abundant, you need infrastructure to turn it into high-purity, battery-grade materials. That needs investment and development, although players like CATL are clearly doing that. Hopefully European firms will too.
And Standardizing the different types.
Yes, there are various sodium-ion chemistries being worked on, optimizing them, standardizing, that's ongoing. And we still need that long-term, real-world validation. How do they perform and degrade over, say, 10 years in a German car or grid system?
But CATL announcing mass production starting late 2025.
Mm-hmm.
That feels like a major milestone for potential European adoption, doesn't it?
It absolutely is. It signals commercial readiness is getting very close, a strong message to the German and European auto industry. So looking ahead, I think we'll see market segmentation.
How so?
High-end EVs probably stick with nickel-rich lithium-ion for range, for a while at least. But mid-range, entry-level EVs, city cars, two-wheelers, big markets in Europe expect fierce competition between LFP and sodium-ion.
And sodium-ion could grab significant share there.
I think so, yes. Especially with the cost and cold weather advantages being so relevant for Europe. CATL even suggested sodium-ion could replace maybe half of LFP demand eventually.
Yeah, wow. And grid storage.
Huge potential there. Sodium-ion looks set to be a major player, competing strongly with LFP and others for stationary storage across Germany and the EU. We might also see hybrid packs.
Hybrid. Combining both?
Yeah, using both lithium-ion and sodium-ion cells in the same pack to maybe get the best of both worlds, some high density from lithium, some cost savings, and cold performance from sodium. It's being explored.
And the bottom line for Europe, it seems massive. Less reliance on critical materials, more energy security, potentially stronger industrial competitiveness.
Exactly. The rise of sodium-ion is, I think, a genuine strategic opportunity for Germany and Europe to diversify, to become more competitive, more resilient, and build a more sustainable energy future right here.
Okay, so let's try and wrap this up for our German listeners. We've heard sodium-ion isn't just some lab experiment anymore. It offers real, tangible benefits. Safety, performance in our specific climates, and importantly, cost savings thanks to abundant sodium. Maybe not peak energy density yet, but it's catching up fast to LFP, making it potentially ideal for loads of applications, affordable everyday EVs, grid storage supporting our energy transition.
Crucial applications for Europe's future.
And maybe the biggest point for us here in Germany and Europe, it offers a pathway, a path towards less dependence on volatile global supply chains for critical minerals, towards greater resource independence, more secure industrial base. So yeah, definitely more than just a cheap battery. It feels like a strategic opening.
It really does. I'd call it a strategic imperative, actually, for Europe to secure its competitiveness as the world electrifies.
Which leads us to a final thought for you, our listener, whether you're in Germany or elsewhere in Europe. With sodium-ion clearly gaining serious momentum, how do we, Germany, Europe, position ourselves? Not just to use this technology, but maybe to lead in its ongoing development, its application across all our key industries.
Yeah, it feels like more than just a tech shift. Maybe a bit of a geopolitical reset button for the battery world, with real implications for European industry.
So what strategic moves should European nations, European companies be thinking about now? How do we maximize the benefits, make sure we're leading this next wave, securing our economic future?
It's definitely something worth digging deeper into. Maybe research some of the companies involved, like CATL, Tiamat, others. Keep an eye on analyses about where battery tech is heading.
Absolutely. It's a story that's really just getting started, but one that's going to shape a lot for all of us here in Europe.